The dimensions of a rectangular floor of a proposed building are such that so we have the length is greater than the width, but at most twice the width. The sum of the width and the length is more than 8 meters but less than 20 meters. If x represents the width and y represents the length, write the inequalities represented by the above information. Part B, Roman number 1, represent the inequalities in part A above on the grid provided, and for Roman number 2, using the integral values of x and y, find the maximum possible area of the floor. So we can start by making a sketch of that rectangle. So this is just a sketch. So we are told that y represents the length while x represents the width. To start with part A, we write the inequalities represented by the above information. We start from here and we say the length is greater than the width. So the length is greater than, so it means y is greater than x. That's what that statement means. But at most twice the width. So what this means that y is less than or equals to 2x. That's what that means. But at most twice the width. Then we come to the second statement. The sum of the width and the length is more than 8 meters. So we can say x plus y is more than 8 but less than 20. It means also x plus y is less than 20. So that is, these are the inequalities that are described there, and therefore by writing these for inequalities, you get 4 marks. So you get 1 mark for that, you get 1 mark for that, you get 1 mark for that, and we get 1 mark for that. So that is part A. We look at part B. Part B says write the inequalities to represent the above information. So to be able to do this on a grid, we are going to use these inequalities to represent this on the grid. So let's do that. So this is the grid that I'm going to use. I have already inserted the inequalities that we have derived in part A. So we need to plot this graph, but here we have inequalities, so we need to write them as equation. So we can write this is y minus x. This is a very simple line. I think you should be able, if you have drawn quite a number of graphs, you should be able to, linear graph, you should be able to plot this line. But without assumption, you can just, if you are not able to get the position of this, you can just make a table that is x and y, and this you have when x is 0, y is 0. When x, you can say when x is 4, y is 4. When x is 10, y is 10. So from there we will be able to plot this graph. Then we have this, we can write y is equals to 2x as a linear function or equation. So we can make a simple table here and say this is our x, that is our y. So we have when x is 0, y is 0. When x is 4, y is 8. When x is 8, y is 16. We are going to use those values to plot this graph. Then this one we can write it x plus y is equals to 8. You can rearrange it and say y is equals to minus 8, not minus 8, but minus x plus 8. So we can make again we can make a simple table. This is our x, that is our y. So with this we can say when x is 0, y is 8. When x is 4, minus 4 plus 8, that will give you 4. When x is 8, this will be minus 8 plus 8, we have 0. So we are going to use those values to plot that graph. this you can write, you can take x to the other side, and you have y is equals to minus x plus 20. Again, we make a table to help us plot this. We have x and y. So here we can say when x is 0, y is 20. That is 0 plus 20 is 20. When x is 10, y minus 10 plus 20, that will give us 10. When x is 20, minus 20 plus 20, that will give us 0. So these are the tables that are going to help us plot this graph. Let's start with let's start by plotting the Cartesian plane. So we can say this is our starting point. Let's say use a scale of 2 for 1 square. So that is 2, this is 4, that is 6, that is 8, this is 10, that is 12, 14, 16, this is 18, 20, we have 22. So let this be our x. You determine your scale depending on the values that we have here. So you can say here x is maximum is 20, as well as y is 20. So that's why I've used that scale. So there along the y-axis we use the same scale. So that is 2, 4, 6, 8, 10. This is 12, and this is 14. This is 16. This is 20. This is 22. So that is our y-axis. Now what remains is now to draw our graphs. So we start with the first, this one. So when x is 0, y is 0. So that's where we have our point. When x is 4, y is 4. So we have another point. When x is 10, y is 10. So you join the 3 points to come up with this straight line. So this is a graph which we can actually label here y is equals to x, and now that is a linear function or equation. So we have now we deal with the inequality. Inequality, we are told y is greater than 2x. So what we do, we pick a point on either side, both sides of the graph, and compare which side satisfies our inequality. Before we do that, our inequality here is x, y greater than x. So this line is supposed to be a dotted line because the values that are along that line do not satisfy our condition. So we make it a broken line. So now that we have a broken line, what we do is we check the side that satisfies our condition. For simplicity, let's take, for example, 0 and 10. So y is 10 and x is 0. Is 10 greater than 0? Yes, that's correct. So that side satisfies. We take the other side, we can take the 10 and 0. Y is 0, x is 10. Is 0 greater than 10? No. So this side does not satisfy our inequality, and therefore we shade off that side which does not satisfy our inequality. So we have now that other side which satisfies our inequality. We come to the second line, y is equals to x. So we say when x is 0, let me use a different color so that you can see it. When x is 0, y is 0. When x is 8, when x is 4, y is 8. When x is 4, y is 8. So it passes through there. When x is 8, y is 16. 16 is there. So we join the 3 points to come up with that graph. So this is the graph that we have, that is y is equals to x. This one will be a complete line because our symbol here is less than or equals to. So the values that lies on the line satisfy our condition. Then what we remain is to check which side satisfies this inequality. We can use the same points that we had used, that is 0 and 10. So we can say x is 0, so and y is 10. Is 10 less than or equals less than 0? no, 10 is greater. So that side does not satisfy. Let's use, we can use another point so that you don't think that it's only that point. We can use 6 and 0. So we say 6 in 0. So 0, 6 times 2 is 12. Is 0 less than 12? Yes. So this side satisfies our inequality. So this is the side that we shade off. Okay, when you are doing it, you it's not a must that you use different colors. I'm using this so that you can be able to see clearly. Otherwise, you just do it with one color, it will be okay. So we have obtained that side. So again, we now move to the third one, which is x plus y is equals to 8. So we say when x is 0, y is when x is 0, y is 8. So we say x is 0, y is 8. So that is where we have our point. When x is 4, y is when x is 4, y is 4. So our point is that point. And when x is 8, y is 0. So the other point is there. So we join the 3 points to come up with the graph. So this is the graph that I have come up with, which we can label as, we can say, we can just write it x plus y is equals to 8. That is the equation, is equals to 8. That is the equation of that. Then we check which side to shade off. Remember, it is, I put a broken line because our symbol is greater than. So let's say, let's take a point 0, 0. You try to pick points which will be easier for you to test which side does not satisfy the inequality. So when you come here, 0 plus 0 is 0 is 0. Is 0 greater than 8? No. So that side does not. Just to confirm, check with another point. For example, we can pick a point like 6, 4. So we say 6 plus 4 is 10. Is 10 greater than 8? Yes. So that side satisfies the inequality. So we come and shade off this side which does not satisfy our inequality. So this is the side that we our inequality. So we shade off that side, and so we are now remain with the last one. So we say when x is 0, this is y is 20. So we come here and let me get a different color. So this is when x is 0, y is 0. When x is 10, y is 10. So that's where we have our other point. And when x is 20, y is 0. So we join the 3 points to come up with the graph. So that is the graph which we get from there, and it is a broken line because our symbol is less than. Now what remains is to test which side satisfy our inequality. We can pick 0, 0. So 0 plus 0 is 0. Is 0 less than 20? Yes. So that side satisfies our inequality. Let's check the other side. We can pick a point like even 20, 20. 20, 20. So we say 20 plus 20 is 40. Is 40 less than 20? No. So it means this side does not satisfy our inequality. So we shade off that side. This side which does not satisfy our inequality, and that is the side. So we have been left with a region which is satisfied by the conditions that we have. So, and that is the question we were told to plot the graph of the linear inequalities that we came up with in part A. So we have done that. So let's go to the question again and see what is required. We have dealt with part B, Roman number 1. We have represented the inequalities in part A on the grid provided. Then we have part B. Using the integral values of x and y, find the maximum possible area of the floor. So for us to get the maximum area of the floor, we need to go back to our grid and check the region to be able to find the maximum possible area of the floor. To get the maximum area, we already have a condition here that x is greater than x, y is greater than x, because y is a length. So if you come to your region here, you find that we cannot take a value that is where y is greater than x. So the value that you get here is 9, x is 9, and y is 10. So we have xy, that is y, x is 9 and x is 10, implying that the maximum area is 9 times 10, which is equals to 90 meters squared. So that is how you answer part C. That is a option that will give you the maximum area in this case. So I think that's we have come to the end of that question. So once you arrive to that point, you are sure that you get 10 marks, and that is a procedure that you follow to be able to work out or get full marks in this case.